The London array comprised 317 turbines in the Thames Estuary in London. And Shell Oil, and this was reported in the Financial Times, and I read it myself, Shell Oil said, okay, cut it in for 40% of the startup cost and the invest with this. And it was part of their green credentials to be seen to supplying green energy. So they have signed up in principle. And when they sat down to sign the final documents, the first thing they were told was, you must build 2 coal-fired power stations on the shore before you can put up a turbine at all. Now, it's clear there that the ordinary generating people in Britain refused to accept the backup for this. So and they insisted on the supplier themselves. So what you actually have with wind power, and it's a very important point, what the wind people are getting away with at the moment is supplying electricity at the load factor into the grid and getting it metered, we'll say at 24% or whatever, so many units per year. And they pay nothing towards the cost of balancing that power on the grid. We, the consumers, our taxes, our levies, and as already very tightly strapped, have to pay for all this capacity and accepting this power. And they're still not happy. They want us to accept it all so that they can just pump it in, get paid, and we carry the cost. And it's very similar to if I pulled up at the petrol pump, filled up my car in petrol, and I said, charge it to you who's coming behind. I mean, yeah, there are costs in most things in this world. If you're in business and you're making something, you have to pay your staff, and you have to make pay your bills, and you have to buy the raw materials and all that, and then you sell on, and the difference is your profit. They are able to get their sales price is their total profit. There's no cost of sales that you would have in an ordinary profit and loss account at all. We, the consumers, bear the entire cost of sales, which is a ridiculous proposition.
Well, I think it's fair to say that without the subsidies, of course, there'd be no wind energy industry whatsoever, because it's totally non-economical from a basic business point of view. But it must be kept in mind that somebody at the end of the day pays for these subsidies. So it's a combination of the people paying on their electricity bill, but even those that are not on the electricity bill, they're paying for it indirectly through taxation anyway.
Well, we pay for it very big, and we're presently paying. The diesel for my tractor, the diesel oil for my tractor has gone up two tranches of 5%. That's 10% in the last 18 months, and it's due to go up and up more as a carbon fine to go directly to these machines. So yes, that would be true.
So going on from that, then the Irish taxpayer could find himself in the not too pleasant situation of, if the energy was being exported, or a better term would be given away perhaps to the British mainland at a big subsidy, the Irish taxpayer could be paying for somebody's heating bill in Birmingham, as you said.
Well, that's correct. And can I just say too that subsidization is not always a bad thing. Certain subsidies are given to people in society, but the key to it is, if you take, for example, farm subsidies here, there are times in the last 10 years when many farms weren't viable and they were struggling, and they gave them subsidies, and people said they shouldn't and they should have. That's all right. But the point is, there was a product produced, and that kept a number of farmers in business that might not have been in it. And at the moment, when we are getting a very, very hard here, we have a terrible economic downturn here, when building has collapsed and all that, meat and food products are exported and the price has gone up. We're just lucky that there's a great demand. And that's money coming into the country that's now very, very useful. And the farmers who got the bit of a subsidy are now de facto paying it back, because they're paying for taxes and paying for buying other things and all that. So I don't have a problem with subsidies for when there's a product. What we appear to be subsidizing here is a waste. And that's a totally different thing. I was just debating this with a man one day, and he said, you might as well get a stuffed camel and put him in every field in the country, and it would be a better idea, because these wind turbines have the potential to actually be negative in their contribution.
Yes, and we must keep in mind that it's a big subsidy. It's 12 billion euros, which is some subsidy. Let's just have a quick look. Moving on here, let's just have a quick look at, you say when the windmill itself, or the wind turbine, is spinning there on a calm day and it's spinning serenely, let's just concentrate on the power that it must be sucking out of the system to keep it spinning. Can you just go into that a bit for us, please?
Yes. This is based on what I'm reading, but I also observed the windmills which are close to me here at Gartnan and Bale and Mountain Lodge and Good Hill. When you put up a large windmill like that, it needs certain services. And one of them, which nobody would begrudge them, I think, is aeronautical lighting. Obviously, if there's no wind for an hour and an airplane crashes into it, we wouldn't begrudge them the wee bit of grid energy for that purpose. Anyone would use it. But it's used also. If you leave a turbine stopped, let's say you took a turbine and you locked it up for 12 months, you run into two problems. One is that it will unequally heat in hot weather, and it may warp, and that's very costly to repair. It would also freeze in the winter. Now, the freezing in the winter might not be a problem if it was parked, but if the windmill stops for a few days and ice forms on it, and then it starts up, the ice could be flung off, and it could go a long distance, and it could injure an animal or injure a person, and it could create an imbalance on your turbine, which would cause the turbine to wobble, and it could do a lot of damage. So there's two examples. What they do actually is they put small elements up through the blades, which keep them heated at a certain temperature by computer automatically. So you need this power there. The other thing is that it's necessary to start them up even in totally calm conditions. And this has been observed in many parts of the world, how in totally calm conditions the windmills are turning. And this is one of the problems from the point of view of people living near them. If these things were upsetting you or annoying you with noise and shadow flicker, and they're actually producing, there would be background wind noise. What often becomes upsetting is when they're doing the same in complete calm, because noise travels. It's like a dog barking at night. You'll hear it much more clearly on a cold night or a still night than you will on a windy night. So yes, they need power for heating. The oil system is a forced pump lubrication in most systems. They do vary, let me say. And in the case of the oil system, it needs to be kept warm so that it's not thick in the morning when the wind comes on. The other thing is they need power to keep them going in marginal wind conditions. Now, I would have claimed they should be shut down in marginal wind conditions. But what they do, in fact, is if the wind is just going high and low above cut-in point, they keep them going by the power so that they're available for any bit of wind comes along and they can claim that. It's also used for turning the knuckle around facing the wind. They call that the yaw mechanism, unwinding the wires coming down from the main generator. But another feature and this is the one I'm most interested in, the generator of a lot of these, without being too technical, some of them is an induction motor type, and it would just need a little power to get started up. And you could get an example of this where they could counter me on this and say, look, it's very little. But if it's what they call a synchronous generator, it means it has a wound rotor. And this is the very same principle as a car alternator. The power for the central rotor that spins round is provided by a direct current through via brushes, or slip ring brushes into the center. And in your car, that power is generated by the generator itself. In other words, if your alternator of your car produces a certain output, we say, of 10 amps, there could be 2 amps taken to fed into this. And a lot of these are now using this system because it's very easy to control it. If the wind suddenly gets up a lot and gets very strong, you can increase the strength of the power into the central rotor, and this increases the torque on the turbine and increases the output. So it makes it much easier to control. That's all right. I have no problem with that. I would have said it should be the turbine should supply it. But from all the information I can get, and this is the question I put to the Minister, it's come from the grid. It's transferred then into the direct current, and it comes from the grid. And what I want to know is that power, and is all the power of a wind turbine, deducted from the net output? In other words, if the total output is 100 and the total power in is 20, is that deducted? Because before they pay for the subsidies and everything, if it's not deducted, or if there's some type of another accounting mechanism, it means that they could be getting the full grant and the full subsidy on the 100, and the 20 they're using from the grid would be accounted for in some other different way. And that would amount to power laundering. Now, I'm not saying it's happening, but I'm getting it very, very hard to get information. And like most things about wind industry, I have to resort to European regulations to try and find this out. Nobody will say, listen, come along and we'll show you and we'll answer these questions. So you have to keep knocking on the door for their little bit and disproving a lot of it, and some of it's true and some of it's false. And this is the point. That's the only way to pay for the power from a wind turbine. But even as that is, as I've already pointed out, if the power is being paid on the load factor, that's the amount into the grid, and there's no deduction made for the cost of incorporating that, then that is a scam in anyone's terms. And a book written on the subject is called a scam. And a lot of people, and some professional people, and I can produce people with engineering and degrees in that of that discipline, will tell you this is a scam. The only way this should be paid for is the actual contribution it makes to society and to saving of CO2. And if that were the case, then they'd only be getting about 1.6% of the actual power, of the actual total possible power they could produce.
All right, that's a very important point. Now, let me just synopsize what you're saying there. First of all, the minister, it's nearly impossible to get a straight answer to a very basic question. Are the generators extracting money from the grid on the 75% of the time they're down? That is the most important question. And you say you just couldn't get an answer to that simple question.
I cannot get it. I shouldn't have to resort. It's not everybody wants this information. I shouldn't have to resort to go on the legal route. And it would be very interesting to see what a reply I get back. There is a process of appealing to the ombudsperson here, Emily O'Reilly, and I'll carry on that. This all takes time, and you're learning all the time. I don't have all the answers. It would be a simple thing to throw the doors open and let's see and explain to people who want to know. And all of what I'm saying, there might be minor incorrections in what I'm saying. I fully admit that, because what I'm calling for is not actually that I'm right and everyone's wrong. I'm calling for an inquiry where we can fish all this out and find out what the position is. We have had a situation here where a building boom was allowed to develop, and when people criticised it, they were told by our Taoiseach, Bertie Ahern, to go and commit suicide. And now I'm trying with others to draw attention to this problem before we spend the money. There's no point looking after we spend the money.
That sounds a reasonable request. I would just point out there now, when you say it's drawing money, it's drawing energy from the grid. A regular person on the street will look up at a turbine and he'll say, okay, there's a generator up there and there's a magnet revolving around and it's generating electricity. But I would point out that that's not the case in these big turbines. There's no magnet up there. The magnetic effect is caused by what's known as induction, where a direct current is fed into a series of coils. And that direct current, that acts in lieu of a magnet. So at any time that there is obviously a power going into the generator before the generator even begins to spin. And when it spins, then it produces alternating current. But there is a direct current going in to generate that magnet effect, for the want of a better word.
Yes, in most cases. There are exceptions. Would you believe that some of them have permanent magnets? In fact, some of the early machines had permanent magnets, and they needed a thing like a starter of a car. They needed a separate starter to keep them going in marginal winds and to get them started up, because there's a cogging effect with a permanent magnet that's not with a wound rotor. If you ever twisted a small motor with a magnet in it, you'll find it clicking. It'll go round in stages. It resists you a little bit, and you get that. Those are made out of rare earth magnets in China, and there's an enormous environmental cost in them. There was an article in the paper, but I won't go into that now. But yes, in the most cases, now most micro turbines, the little ones on houses, they all mostly have permanent magnets. They're the simplest thing. The permanent magnet, though, has the disadvantage that it only allows maximum output within a narrow range. Because if you've got light winds, it's too strong. The wind's not able to bring it round. If you've got real heavy winds, it can bring it round, but it's not able to get up the voltage. A very good example of that, if you hire out a little garden generator, a little small generator there for working a drill where you have no power, it has a permanent magnet in most cases. And if you run a drill or a saw or anything off them, lovely. If you try to weld with them, it won't weld, because the permanent magnet is not able to rise up to the pressure needed to counter the coils. So the permanent magnet isn't as successful, and they seem to be going over more to these. And I have checked the websites for the specifications of some of the turbines, and yes, I'm reasonably happy that a good few of them are this type. They call it a synchronous motor. It produces the frequency produced is directly in line with the poles of the magnet, whereas a permanent magnet is the same. There's another type called an induction motor, also called a squirrel cage type motor, and it operates on slippage, and it's a bit technical. It only needs to be touched, but it again suffers from the problem where it can't rise to very high power. It'll stop, it loses magnetism. So they do vary. I want to make that point, because you'll always get someone to point out the exception. But what I'm saying is, as you put the question, where there's a wound rotor, why can't the windmills themselves provide the power for them? Why do we draw it from the grid? Seeing that the whole point of these windmills is to save fossil fuel, and this is the whole point I'm making.
Okay. Can you give us a bit of a explanation there about the subsidies and the grants that are given to the windmill generators?
Well, I know for a fact that the published amount up about last year